Welcome back to module 11 of object oriented analysis and design. We have been discussing about nature of objects. We have noted that an object must exist, it must interact and it must be distinguishable. And taking from there, we have noted that every object will have state, behavior and identity. We have talked about state already. We talked about state charts, how certain part of the properties could be static and certain part of the properties could have dynamic values. Now, we move on to discuss the behavior of an object. The behavior of an object is a collection of its operations. So, I have a stack object. It has some properties of course, to store the items being stacked, to mark up what is the top of the stack, but what we are more interested now is the fact that it has different operations. So, these operations together define the behavior of the stack. So, we can, if we just look at specifically, then this these two operations define the LIFO behavior of the stack, last in first out. These four together basically defines a stack. But in addition, I have also provided another operation to extend the behavior. This operation of print is primarily for the purpose of debugging and for purpose of illustration. For example, if I am creating the stack object, implementing the stack object, and then I need to understand at every stage if my stack operations are working correctly, and I might need some help to print the state of the stack at any point of time, and therefore, I have a print operation. So, behavior will talk about all of these together as a collection, and I know that search is not a part of this behavior. Therefore, I cannot search an item in a stack. That is a basic notion of a behavior. At this point, I would like to draw your attention to the client server model of object based interaction and computation that we had introduced earlier. That is the fact that no object can exist in isolation. An object in isolation has no interesting aspect to talk about. So, objects are acted on and they themselves act on other objects. So, if I have object O1, I have object O2. So, O1 acts on O2. So, this is acted on and O1 acts on O2. So, either you are acted on or you act on other objects. And this is what we have seen leads to the basic client server model. The behavior is a set of services or operations provided by the object. Services are requested by, these are just variants of the terminology. Services are requested by either sending messages or invoking operations. And in summary, in the client server view, clients request for services, the servers naturally provide services, client request for service, the server provides the service, and what carries it through is a message which has to be done according to a contract, according to a protocol which is agreed between the client and the server. So, this set of messages or operations basically define the behavior of an object. Now, of course, the objects could have variety of operations in its behavior, but several years of experience of different people in designing objects, in modeling systems have led to the observation that there are 5 basic types of common operations that usually happen for an object. So, while we are designing the object, it will be good to understand what kind of operation we are adding to the whole behavior set. So, these behaviors include, the first is called the modifiers. A modifier is an operation that will change the state of the object. Now, we know what is the state of the object. So, if I talk about the stack, then push is a modifier, because push, what will happen if you push? Naturally, a new item will get into the store and the marker will move the top position. So, both these properties that the state has will change their values, therefore, the state of the stack object will change. Similarly, if I do pop, again some value will be removed, even if you assume that removal is not a physical rewrite of the store, certainly the marker has to move to mark that the top position has changed. So, the state of the object will change. So, these are modifier kind of operations. Then I could have selector kind of operations, which accesses the state, but does not change it. When I check the top element, or I check if a stack is empty or not, I am not changing the store or the marker, but I am just checking out something based on their values. A third class of operations are called iterators, and these are very powerful type of operations, which basically goes over all parts of an object and does something, accesses, performs something in a well behaved manner, in a well defined manner. So, if you just look at, consider the print function in the stack object, you will find that it is an iterator, because what does it do? It iterates, goes over each and every element of the store that the stack has and prints it to the output. So, different kinds of prints and different kind of ways to go over the different parts of the object in an organized manner is the behavior of the common iterator class of operations. So, these are basically what comes from the functionality of an object. Certainly, what needs to be there in addition to this are the constructor operations, which actually create the object, and the destructor operation by which an object annihilates itself. So, though I have not explicitly shown, a stack will need a constructor to create the stack, and it will need a destructor, so that it can destroy itself when the job of that stack is over. So, whenever you design objects and you define its behavior, try to be clear in terms of which category your operation falls in. It is usually a good practice not to write very complex operations, which could do multiple of these activities in the same operation. That is, it modifies as well as iterates, and while it is doing a construction. So, it is better to avoid these kind of complex operations for the ease and clarity of design. So, this is another example for primarily for your self study. I have taken the an object instance from the LMS example, an employee, and I have shown that for that employee all the different kind of some of the operations that you can have, how those operations are classified according to being a modifier, being a selector, being an iterator, or being a constructor or a destructor. You can see the constructor is here, the destructor is here, and so on. We have roles and responsibilities of behavior. An object which is not very simple will certainly be having a large number of operations, and as it happens that often these operations are kind of groupable. I can put similar operations, interrelated operations together. So, in a total behavior, if I group the operations according to their semantic commonality according to their interdependence, then I will get the different roles that the object play as a part of the behavior. And it is possible that roles may overlap, that is, two different roles may have certain things which are common. So, just to take an example is if we look at the different activities that the employees do in our leave management system, we have seen that there are some employees perform the role of being an executive. That is, their main task is to work, primarily is to work for the organization. But some employees whom the document says are lead employees certainly take reporting of other employees, executives, and guide them, providing leadership. So, those who work as executive do not have this role of leadership. Those who are lead or manager, the LMS specifications say, can actually approve the leave for others, can revoke and approve leave, can regret an applied leave, and so on. So, they have yet another role, which is what I am calling here as an approver role. Then managers are certain employees who have management roles. For example, they can decide how much leave an employee should get, and so on and so forth. So, this is the context of having roles in behavior. It usually becomes a cleaner design if we have a clear understanding about the different roles that the behavior of an object will have, and every role will then be associated with the responsibilities or the set of operations that particular role is expected to perform. So, this is again for your self understanding. These are three objects being shown from the LMS system, and the leftmost one is for an executive. So, to illustrate that, I have introduced a property called designation. So, the leftmost one is for an executive, next is for a lead, next is for a manager, and here you can see what are the roles that these objects will play. Now, if you look into the operations, you will find that this role of an executive is responsible for these operations, that is, recording his or her own attendance, applying for leave, cancelling leave, availing a leave that has been approved, and so on. So, the executive has, so if the role is of an executive, then these are the roles, these are the responsibilities. Now, if we look into an employee object which is for a lead, then certainly that employee has an executive role and associated responsibilities, but the employee also have other roles like leadership and approver and associated responsibilities of approving leave, revoking leave, taking reporting, and so on. If we look into the manager, we will have yet one more role and the associated responsibility for that role. So, as we can see here that different objects, all are employee objects, their behavior has different roles, and the roles in this case are overlapping. For example, a lead employee actually performs two roles, the role of an executive and the collective role of leadership and approver. A manager performs all the four roles, and correspondingly they have overlapping responsibilities to perform. So, it will usually, of course, it is not mandatory that you will have to define or you will have to demarcate what are the different roles of a behavior and the corresponding responsibility, but as it turns out, it usually gives you a better design if you are clear in terms of the different roles in the behavior of an object that you define, and you are able to associate the operations as responsibilities of different roles. So, to summarize, the behavior of an object is how an object acts, and reacts. Act means proactively, react means in response to what somebody else has done in terms of state changes and message passing. So, if the state changes, naturally the object will act, and if the message has been received, the object will react. The state of an object represents the cumulative result of its behavior. At any point of time, all these operations as performed, we have seen whether particularly as we have seen that if we are any kind of modifier operation, then the state will keep on changing, and that is the result of the behavior that we will get to see. Next, we have talked about two aspects of state and behavior. Next, let us talk about the identity of an object. The identity of an object is, as we started saying, that every object must be distinguishable. So, that is the simple thing. The identity of an object is that property of an object which distinguishes it from all other objects. So, that is something very critical for the objects to exist and behave. Without the identity, we will not be able to actually do any reasoning in the system. Now, how do we put the identity? How does an object get the identity? There are grossly two major ways the identity can be thought of. One is, objects may be distinguishable by the state. That I can say that if I know the state of the object, I know which object it is. How do I do that? It is very difficult to do that, but I will be able to do that if the object has at least one unique property. I mean, those of you who are familiar with some bit of database systems, particularly of the relational kind, will identify this unique property as a key. Now, it may be a single property, it may be a collection of properties. The uniqueness here mean that a property is unique or a key if for any two objects that I can have, if that particular property will always be taking different values. So, consider the employees in the lease management system. The employee object has an employee ID. Naturally, there cannot be two employee objects with the same ID. So, therefore, this is a distinguishable property, and the object, no matter what else happen, just by the state of the object, which comprise of various different properties like the name, the date of joining, and whether the employee is on duty and so on, will also have the employee EID, and will be able to distinguish an employee object by the EID part. So, that is one way of distinguishing objects, but you can just extend that if we are talking about complex objects, then we may not be possible to distinguish two complex objects by their state or by the value of RE and IM. I can have two complex objects which have the same real part and the same imaginary part, and they are just two different objects. So, it is not necessary that all objects will have a unique distinguishable property. So, the objects may be distinguished by the identity that is ascribed on an object by the system. That is, the system says that, well, to distinguish an object based on, or to identify an object, or to set up identity for an object based on a distinguishable property, kind of I open up the object, look into the state and say, well, it is this object. But instead, the system that manages these objects could put an ID on top of that object, and this is what is done typically in a lot of programming systems. For example, those programming systems which are based on framework, I would just remind you that we had talked about the fact that in the evolution of programming languages, we talked about that a major part of the recent programming systems are based on framework, where there is a certain runtime that runs like JVM for Java or .NET for C# and so on, which manage the objects that exist at the time of execution. So, if there is a framework that goes with the programming system, then the framework may attach an ID to an object. So, it does not need to look into what is the inside state of the object, but based on the ID that it attaches separately, you can figure out what is the identity of an object. But systems which do not have or the programming systems or the programming languages which do not use a framework, that is, do not use a separate runtime system, would not be able to do this. So, for them it is typically the address of the object gives loosely or works loosely as an alias for the ID. So, you say what is the identity of this object is wherever it exists. Now, this kind of an identity is somewhat difficult to work with, because you will understand that without changing the object in any way, if I just relocate the object from one memory address to another, then potentially I would be impacting the identity of the object. So, we will have to be careful in those systems in terms of dealing with the identity of the object. So, to look a little bit more into this, let us just consider a simple example. This whole example is very well developed in the book, in the OOAD book. So, it is just taken from there. It talks about display item is a common abstraction in GUI centric system. So, the idea is you have kind of a canvas, the GUI canvas, and you have different objects on that canvas. Okay. And where they occur in the canvas is defined by a pair of values x and y coordinates of the center of that display object, let us say. So, here in this instance it shows the four different four objects. This is item 1 is one display item, one display object, and item 2, 3 and 4 are pointers to display items. Of that, item 2 points to this particular display item, which is unnamed, but you can still identify it by the pointer. Item 3 points to another, and item 4 is kind of a dangling reference, which currently does not point to any display item. So, you can see that in this case we have different identities. Some are maintained directly by the object as in item 1, or indirectly through the pointer if there is no direct identity of the object. Now, let us see what happens when some operations start happening with this, that the unique property that each object will preserve through the over the lifetime is the identity, even when its state will be changing. So, let us say on that canvas, on that GUI display system, suppose item 1 has been moved. Item 1 has been moved. So, earlier it was in 0 0 and now it has been moved to a location 75 75 75 75. How did we move that? We used item 2, got the location of this unnamed object, and we have moved item 1 also to that same location. Now, suppose we equate item 3 and item 4. Item 4, you remember, item 4 earlier was pointing to null, it was not pointing anywhere. Now, we have equated 3 and 4. So, both refer to the same object. So, basically two different references, but the same object. And using item 4, we have actually edited the x coordinate, that is, we have actually moved that object. Therefore, if you try to access it through item 3 also, you will get it in a new location. So, what we can see that item 1 and item 2 have the same state, both are located in the same 75 location, but they necessarily represent distinct objects. This is the crux of the identity, that a state may not actually define everything. Here, where is the identity coming from? The identity here is coming from the identity that is written on the item 1 object, and the identity of the pointer which holds this unnamed object, which holds this unidentified object. Let us go further. Let us see what if we modify. So, we are just asking this question, what if we modify the value of the item 2 pointer to point to item 1. So, earlier it was pointing here, we change and we make it point to item 1. So, now what will happen? Item 1 and item 2, basically both of these actually mean the same object. So, two identities, but actually they mean the same object, and the worst part is this particular object has lost its identity. It did not have it was not named, it was not designated anyway, it was identified by the pointer which was holding this address of this object. Now, that has moved on this side, this pointer is gone, and therefore, this has become kind of lost its identity, and therefore, it cannot be accessed, cannot be managed directly or indirectly. So, when you can see that identity of an object is not only it is critical in the sense of abstraction, because unless the objects have identities, how do they interact with each other, how do they act and react, which the behavior need, but we note that their identity may not be always derivable from the state they are in, or certainly the kind of behavior that they demonstrate, but identity is a third dimension to an object, where you will need to somehow be able to distinguish objects, and two objects having the same state can still have different identities, and then object who has lost its identity is lost for the system. And so, in the design all these aspects of identity will need to be borne, and now we come to the final conclusion. So, this is I would like to conclude with this nice kind of cartoon from the OAD book. It says what is the state and what is the behavior. The state basically says all this is a grade 1 hammer kind of handle, the steel head and so on. So, those are the different values of the properties which define the state of a hammer. This is certainly the behavior. The behavior of the hammer is to hammer in the nail, and the identity is this is my hammer which stands still amongst the pool of different hammers. A symbolic diagram, a representation, but very clearly brings out the core point of the nature of an object. To summarize on the module, we have seen that an object has state, behavior and identity. A state is defined by the values of its property, and we have seen different variations in that in terms of static property and property that have dynamic values and so on. The behavior is defined by the collection of operations. We have seen what are the different common operations that the behavior should include, and we have also talked about how the roles of a behavior should be properly identified to designate the responsibilities or the associated operations that every role must have. And finally, we have seen that identity provides the distinguishability, and it could be inherent to an object if there is one or more distinguishable properties, but in many cases in the absence of such key properties, an object may need to carry an identity which is either provided by a dynamic framework supporting the whole object based implementation, or merely by the location of the object or the address of the object, and there are potential risks in terms of those, some of which we have already shown. So, finally, the objects occupy space and either in the physical world or in the computer memory, and it is very critical to keep in mind that an object must exist, must interact and must be distinguishable.